Yeah.
Okay. I had heard, yeah, but did you watch the other videos too, or just the live stream ones? Or sometimes both?
Yeah.
What?
I usually just watch our classes live stream if I need to refresh on something.
Cool. How do you know which one it is? You can look at the date.
Yeah, I just kind of figure out, and then if I don't recognize the people, I realize it's not our class.
Okay. All right, yeah. And it doesn't blot the screen out. It sometimes does it blot out the math work or whatever. So that's one of my big fears. That it will blot it out, but
No, I've always been able to see everything.
okay, good. All right, I'm sharing screen, right? Our live stream is on. We're on. So let's do today. Today is so I gave you more time. I don't remember, but today what's supposed to be due on the 12th is quiz 9 and mod 10. And so, but I think I gave you more time. So I think we're still lingering in mod 9. I think we went over quiz 8, but I think we need to go over quiz 9. But I think quiz 9 is due later today, maybe. Is that people's impression? So let's take a look at mod 9. Okay. I feel like we did mod 8, so I'm just not going. Let me see. I'll know when I do this. Oh, we definitely did mod 8. Okay, so mod 9. Let's see. Only 6 people attempted it. So last class, only one person attempted it, so I only had 5 questions to do. The more people attempt it, the more questions there are. But for this one, I'm going to go over these first few questions that are looking pretty hard. Okay, so let's start with this one. Lines 8 and 9. What happened here? Okay, so there's a function, and there's an area under the curve, right? A definite integral, and then it's divided by the limits of integration. Does anyone know what that is? Take the area and you divide it by the length. What do you get? Area over length gives you not use integral properties. Find the area using the fundamental theorem of calculus? No. Using geometry to find the area? No. There it is. Find the average value of a function in a given interval. Okay, average value is area over length. That's the average value. Okay, position plus none of the other ones. Any questions on that? Okay, that is an important one to do. Okay, so now we want 35 and 36. I'm just going to hit 35 and 36. Okay. All right, so I think this is poorly written, but I know that that's a definite integral, and these capital F's are antiderivatives evaluated at the 2 endpoints. What is it that takes the definite integral and evaluates it between 2 endpoints? What's the theorem that does that? What's the fundamental theorem that does that? Anyone? Carlos, what's the fundamental theorem that connects the antiderivative indefinite integral with the definite integral? Oh, who's talking to me? Alicia? What's the theorem? Okay, it's not integral properties. It is the fundamental theorem of calculus. Okay. Find the area using the fundamental theorem. That's the correct answer. That's what's going on here. The fundamental theorem says Actually, what's technically happening is that they're finding what the antiderivative is. That is the fundamental theorem. And this is the antiderivative. So I suppose a correct answer might have been, did they say, someone say use integral properties? Yeah, you know what? That's probably the right answer. It is the fundamental theorem, but as we've been saying, that's the first line is the fundamental theorem. This is just integral properties to figure out what the antiderivative is. So my bad, this should be a different answer. Somebody wants to ask me what that is later. I'll fix it. I don't know who you are that had that question. But yeah, I think that is integral properties. Okay, now this one here. So this is misleading because they have this shaded region and it's defined for everything. It's defined for all values of x, but they have the shaded region. But the question says find the area under the function between 0 and 2. Okay, so if you want the integral from 0 to 2, this is some shoot, I don't care. Okay, so if I want the integral from 0 to 2, of this function, f of x dx, it's defined to 1. It changes at 1, so I have to change. So I have to, I don't know what this function thinks it is. It ain't that. Okay, so I'm going to take between 0 to 1, and I'm going to add from 1 to 2. Okay. No. Okay, so I'm adding from 1 to 2. Now, between 0 and 1, the function is 2 minus x squared. 2 minus x squared. That's what the function is between 0 and 1. And the function between 1 and 2 is just 0.5. Just change this to 0.5. And then the answer becomes 2.2. I guess that would be 2 and 1/6 or 13/6. And you know why people got it wrong? Because it's shaded in these 3 regions, and I think they included this first region. But in fact, it only says between 0 and 2. So my answer is correct, and the question is correct, but probably the person who missed it added in that part right there. Okay, that part would be the integral between -1 and 0 of 1 minus x. So I'll be an extra 1.5. Okay, any questions on that? Questions? Aiden? You okay?
Yeah.
Okay. Still don't know who missed that question. Okay. All right. Find the following. Okay. So this is the derivative.
这样的妈妈，
Eric. You okay? This is the derivative of the antiderivative. Okay. Do you know what happens when you take the derivative of the antiderivative? What undoes a derivative?
下完以后就给自己看一下那个手机。
What undoes a derivative? Anybody? Slade, what undoes a derivative?
An antiderivative?
Yes, very good. Correct. So if you're doing both of them at the same time, one's undoing the other. And the answer is just going to be this function, the sign of, but instead of it's going to be not t, it's going to be an x because the variable up there is an x. So you're going to replace the t's with x's. So it'll be the sine of x plus 7x plus 15. Okay, you don't have to do any calculations, but if you do decide to do calculations, if you do, and you can say the integral from 0 to x of the sine of t plus 7t plus 15 dt. Okay, and so I do the antiderivative. I use the fundamental theorem of calculus. So what's the antiderivative of sine? Minus the cosine. Minus cosine of t, little t. The antiderivative of 7t is 7t squared over 2. Plus, what's the antiderivative of 15? Pam, what's the antiderivative of 15? 15.
No idea.
What's the derivative of 15? What's the derivative of 15? That's 0.
Oh,
What's
0.
the antiderivative goes backwards. So what would give you 15? The derivative of what would give you 15 is if there was something there, like t maybe?
15t.
There you go. All right, so now we have to evaluate. So that's the antiderivative. So this is a fundamental theorem. So I'll just put the fundamental. So this is f of t. That, and now I'm going to have to do for that fundamental theorem. I have to do f of x minus f of 0. Okay, and that equals, I'm gonna expand this. I want to see a lot more of this. Okay, so I have to take this whole function right here and put x's in, change all those t's to x's, x, 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 and then I have to do minus parentheses and do all the same things, only put zeros in. 0. Zero. Okay. And that becomes, so this whole integral right here by the fundamental theorem of calculus becomes all of this except the cosine of 0 is 1. So it's minus 1, and everything else is 0. 0, 0, 0, 0, 0, 0, 0. So minus the negative 1 is plus 1. It really doesn't matter, even if you get it wrong, it's not going to matter, because the next thing you're going to do, because it says in the problem, it says take the derivative of both sides. dx of this side means taking the derivative of this. All right, Pam, now you get to redeem yourself. Uh-oh. What's the derivative of all of that? What's the derivative of minus cosine?
Oh, sine.
Okay. I'm going to ask Pavani for the next one. What's the derivative of 7x squared over 2, Pavani? Hello? Pavani? Acacia? Hello? Alicia?
Yeah,
Hello? What's the derivative of 7/2 x squared?
7/2 x squared.
Bring the 2 down and you get what?
The derivative of it?
No, it's just regular derivative, not antiderivative derivative.
Is it going to be 7x to the third?
Oh, that's antiderivative. 7x.
Oh, sorry, 7x. That's
Nope.
it.
That's it. The 2 cancels with the 2, and you just have the 7 hanging around. Okay, what's the derivative of 15x? I'll ask Pavani again. Thank you, Alicia. Or Carlos, what's the derivative of 15x?
15.
15.
Thank you, both of you. What's the derivative of 1? It's 0. So do you see how I get for this answer? I went through all that work to just find the exact same thing that was in here. Only they put x's in instead of t's. See, the same answer. Okay. And so you didn't have to do all this work. You could have just gone right to the answer. Okay, and it's okay to do that because it's the derivative of the antiderivative. Okay, question. Why did people miss this? Find the area of the region bound by this. You can answer to two decimals. Yeah. Find the area bound by, I guess that's a number like 3x squared. 3x squared. And x equals 2 and the x-axis. Okay, so where is that? So that all that is the integral of 3x squared. Oops. 3x squared dx. And that's going from, it's going up to 2. But if you look at the graph, hold on, there's a lot of stuff here. Where's that purple one? Okay, so if I do y equals 3x squared, okay, and I do x equals 2, and the y-axis is y equals 0. They just all they want is the area in this region right here, which is from 0 to 2. Starts here at 0 and goes all the way to 2. Okay, so that's how I know it goes from 0 to 2, and the answer is 8. Okay. Like this one. So this is so. Let's find the position function S of t given the acceleration function before. Okay, so these have numbers like 9 and 8 and 7. And use it to find S of 1. Okay. So we have to start off with the first thing, that the acceleration is equal to equals 9 minus t. How do we find the velocity? What do we do to find the velocity? Sebastian, what do we do to find the velocity? We have acceleration. Do we take the derivative or the antiderivative?
Derivative.
Antiderivative, because we have the acceleration is this. Acceleration is another for the second derivative, and velocity is the first derivative, so we have to go back. So I need to do the integral of this dt, and I have to do the integral of this dt. Okay, and that's going to give me the velocity. Okay, let me make this bigger. Okay, what's the antiderivative of 9 minus t? What's that equal to? Oh, what's the antiderivative of 9? 9 what? What's the antiderivative of 9? The derivative of 9 is 0. The antiderivative of 9, again, it goes up to 9t. What's the antiderivative of t? That's t squared over 2 plus a constant. Okay? So you guys should start getting better at these antiderivatives. I hope you are. Let me take all this stuff out and just leave it here. So now I have v of t is equal to that, right? So then they tell you v of 0 equals 8. So you can take this and plug 0 in. V of 0 is 9 times 0, which is 0 squared over 2 plus a constant equals, all of that equals 8. So 9 times 0 is 0, and 0, so that just says, is another way of saying c equals 8. Okay, so I go back to my velocity question. And I put 8 in here. Okay. They don't ask you that. They even more, that it looks like they need the position function. How do I find the position from the velocity? What do you think? Derivative or antiderivative, Aiden?
The antiderivative.
Right. That's going to give us the position function. Okay, so what's the antiderivative of 9t?
9t squared over 2.
T squared over 2. Very good. How about t squared? That's going to be t cubed over 3 times 2 is 6. What's the antiderivative of 8? Just 8t. And then there's a constant. Okay. Back to the original problem. S of 0 equals 7. So we still have to do this. What does that mean about this? If I plug in 0, what do I get? S of 0. That's going to be 0 minus 0 plus 0 plus the constant, and all of that has to add up to 8. So what does that tell you the constant is? Constant equals 8. So the position function, all of that, and that's an 8. Okay, question, what did they ask you? They've not done, they asked you, use it to find S of 1. So there's S of t. How do I find S of 1? What's S of 1? I just type it in if I've done it right. Oh, it won't do it. There's too many S's. One way I can do it is to just there, it's 20 and a third. What it is, or 61 thirds. Okay. Any question on that? Questions on it? All right. Well, only one person had that. They didn't get it. Okay. How do we find exact area? Anyone who has Carlos, have you been here? Can you tell me how to find exact area?
I don't remember.
Well, there was lots of different ways of finding exact area. Anybody at home tell me how to find exact area?
Length times width times height.
That would be volume.
Length
Anyway.
times width then?
Here, no. You can use the definite integral. Or you can use the fundamental theorem of calculus. Or you could use Desmos. Or you can do you can do a lot of rectangles to approximate the area exactly. An infinite number. Okay? Say this. All right, so this is just the same thing repeated over and over again. It's the derivative of the integral from 0 to x of f1 of t dt. Okay? So that's what you have to say. Derivative of the integral from 0 to x of the given function. This is the derivative of the integral from 0 to x of a given function equals the sum of the derivatives of the integrals from 0 to 1 and 1 to x. So yeah, they're just saying that you can, the derivative of the integral of one of the from 0 to x is the same as 0 to 1 and 1 to x. Okay. And this to use the integral to find the average distance from home. To find the average distance from home. There's no average distance formula. What is the average distance formula? What's the average value formula? If the distance is a value, it's not a rate. So we don't want the average rate, we want the average value. Okay. Anyone? Sebastian, what do you think? Going from where to where in this question? Well, let's go from 0 to 5. So it's 0 to 5 of the function. Check. So that's the area under the curve. It's 871. Is that what you want for the average value? Let me just. I'm talking about between 0 and 5. I'm talking about 0 less than 1 less than f of x. X is okay, that's that shaded region right there. The average value of that, if all the values between, are we doing 0 to 1 or 0 to 5? 0 to 5. All the values in there on average have to be somewhere but a little less than 200. It can't be higher. It just can't be. So what do you have to do to find the exact average value? You go from 0 to 5 of f of x dx divided by what?
5.
Thank you. 5 minus 0 or 5. So that's the answer, 174. If you look where 174 is, you do y equals it. It'll give you a horizontal line. Y equals, do you see how that's right down the middle pretty much? Took all of this and put it in there, that would be same area. Okay. Any questions on that? Okay. Moving on. What happens to lines 14 and 15? Oh, there's 100% on this, so I'm done. Okay. That's the end of this quiz. Finish it by tonight. This is quiz 9. I think it's due tonight. Yes? Okay. All right. All right, let's move on to your discussions in 9. Discussions. Okay. Acacia. When Jonathan did this. Jonathan, you want to read what you wrote there?
Yeah, according to the Quartic regression, between 1 and 13 hours of study, there was an average grade of 45.9%.
So do you think it's good to study between 1 and 13 hours? That's my question to Jonathan. Is it good to study between 1 and 13 hours? If your average grade is going to be a 45.
I mean, it's better than a 0, but no.
So good answer. If you clicked on this, that's your, I don't know if I can do it. Is this going to work to put it in as a text? Okay, so have you ever done this where you've gone to this link?
Sorry, can you repeat that?
Oh, so Acacia, I just pulled up your link. If you instead of 1 and 13 hours did something like 20 and 25 hours, your average grade would be what?
90.
Yeah, that's what the grade, that's what you should be for. You should be lucky if it only takes that many hours to ensure a grade like that. You should be lucky. Okay, next post. Alicia. I haven't seen you in so long. I barely remember what you look like.
Try to come back on Thursday.
It's okay. Don't do it. It's fine. All right. So I see Alicia posted something that Pam was able to write. She did both of these. One was billion people years, and the other one was billions of people. So Luke, do you want to say what you wrote there? Is Luke here to say what he wrote? Otherwise, maybe Pam could read that. Pam, could you read that?
What Luke wrote?
Yeah, what Luke wrote.
Yeah.
Here.
According to the Quartic regression, between the years 1980 and 2010, there was an average of 5.7 billion people. That's
Oh.
it.
Great. Perfect. Thank you, Pam. Okay. So what happened? Hello? I don't know what's going on. Okay. That'll work. Okay, next post. Sebastian. Oh, Aiden gets to say. Aiden, what are you saying?
I'm saying that according to the Quartic regression, the average drug potency is 102 micrograms per cc from month 1 to month 5.
Okay. Here we come. Post 4, Slade. Oh, Selena taped something.
According to the Quartic regression, between 75 and 100 BFX, there was a total salary of 92.31K, which represents an average salary of 3.69K per BFF.
No, I don't think so. If if the integral, the first one, which was the integral between, I forget, 75 and 100 is 92. That's 92 BFF $1,000. When you divide it by 25, you're dividing it by the $1,000 parts, and what you're left with is the 3.69 BFFs. Okay. So remember, in the end, you're getting the Y value. All right. Any questions on that? All right. Fix it. If you can. Did I get everybody's week 4? Okay, so now let's move on to week 5. Not week 5. I was supposed to. Let's move on to mod 10. Okay. So for mod 10, we're going to break up into our groups and we're going to work on the approximate area. And all you have to do in the approximate area is this. So watch and learn, especially if you're a producer. Okay, if I go down to mod 10, I turn on mod 9, and that's what I'm trying to approximate. Okay, then I open up, I can click on this, and nothing's going to happen. I have to open it up and say below is the exact area. There's the exact area, 10,800. There's the fundamental theorem of calculus. Here it is getting the answer, 10,800, fine. Okay, and now so that's one answer I need to see. So line 81. But anyway, then the rest of this is just approximating with 4,000 rectangles. You get a very close number. If you do 40,000 rectangles, it's even closer. Okay. All right. So the writer below is saying the antiderivative of 20 minus the antiderivative of 0 is 10,800. That's because you're trying to write down what the fundamental theorem of calculus says. And then here's what the writer says for the summation stuff. You just wrote exactly what's written here, except you plug in A1, B1, and N. Okay, just plug it in. All right. But, okay. Speaker. The speaker is going to say, according to the quartic regression, between 0 and 20 hours, and using 4,000 rectangles, evaluated at the left endpoints, the trip uses approximately 10,800 mile hours. Okay. So you don't I didn't do anything except for the writer, you have to take this and replace the ends with whichever the producer has in there. Change it from 4,000. Make it 40,000, make it 400. I don't care. Change it.
5,000, 5 million.
You can do 5,000. You could do 5,000. The answer is not as good. You could do 5 million.
How about 1 billion?
I don't know, but you can do this, but it's not giving me any more decimal places. So I think it's as good as it can be. All right, let's break up into our breakout rooms. Okay, and let's work on this. Okay, do you know what room you're in? Yes.
So, Professor, all we need to do is change the n value, the number?
All you have to do is change the n and then mention it. If you're the speaker, you have to say how many rectangles used to approximate and get the answer. Uh-oh, I got the wrong thing. Hold on. Sorry, I have to try this again. Breakout room. Are you guys in the right breakout room, or did it assign them automatically? It looks like they assigned them automatically. Because Jonathan is with Alicia.
And we're in two.
Just have to wait a second until it takes 30 seconds. You can all tell me anything else you want me to say. So I'm giving a talk on Friday to the distance learning people about this stuff that we do. So if you have some comments and you want me to pass it along, let me know. Stuff you like.
So, Professor,
Yeah.
so as the producer, we don't need a plug-in for A1 and B1, only N.
A1 and B1 should be whatever it was before. Leave the A1 and B1 alone. Just plug
Okay.
in for N. But make sure that the other people know what it is, A1 and B1. Okay, there we go. Let's get into some rooms. Sebastian, you're with Aiden. What room are you in? 3. I can't put you in because it keeps moving. Sebastian, Aiden, in room 3. Slade and Eric are in 1. Yeah, and Alicia. Okay, sure, and Jonathan. Slade and Eric. Selena, what room were you in? I'll move you.
With Slade.
It was with Slade. Okay, Slade is with Eric. So
I'm with Sebastian and Aiden.
what?
I'm with Sebastian and Aiden.
Carlo?
I don't remember my room.
There you go. 3.
All right. Thank you.
Join room 3. I think Aiden and Sebastian are already there. Oh, no one's here. How you doing, Sebastian? Good. I got Sebastian. Yeah, Sebastian. It's Aiden there? Are you talking to him on the earbud?
In the chat.
Oh, people in your chats.
Yeah, but I already posted it because I accidentally did it last class. Because I
Oh.
thought we were doing a quad 10.
Do they know what to do?
Yeah, I already submitted it and gave it the link.
Make sure it looks good because I'm going to go over it before we move on. It's technically due today and I want to be done.
Okay.
I think it's neat. So you use the chat. So you go into the breakout room and use the chat.
Sometimes I use like actual speaking and whatnot, but since I already posted it, there's nothing to really, because Aiden was here and he helped me with it. So we did it, and so there's nothing to really talk about.
Wow. Is this a project that have you done this sort of project work before?
Like on Desmos?
Anything like this? No, not on Desmos, on breakout rooms and having groups and I don't know.
I mean, with Zoom breakout rooms, I had to do it, because of COVID.
But where you working, what were you doing in the breakout rooms?
We would just be with our,
Breakout room?
breakout room, and then she'd assign us some like work to go over as a group or something like that. I don't really remember because it was like 4 or 5 years ago. Oh, 4, but,
And it wasn't anything, but it was nothing like this. This is sort of different. I'm guessing.
kind of different, not like super different where I'm like confused as to what to do, but like there's just a bit more I had to learn, but it was relatively easy.
Right, the calculations aren't difficult, especially since I will set it up for you, but it's. I hope you appreciate that you've been working with the same set of data the whole time.
I do, it makes it so much easier and it helps me understand the question, how to incorporate it.
And that's the thing I don't like about group work that I've done even I've done it. It's with lesser math classes, is that it's like we're doing problem number 6 today. And the next one we do problem number 7, and they're totally unrelated problems. They're not. This is the same topic being developed. This is good for if you want to apply for a grant someday, you can develop the whole thing from beginning to end and have a whole lot to say. Do you know what I'm saying? That's what I'm trying to get to. I tried to give this a demonstration of this talk that I'm giving on Friday to a friend of mine who said sort of important. And she said, it's too much. She said, it's good to be in the position of being able to weed stuff out, but you need to weed out like half of what you said. Like, oh.
And I want to double check, it's supposed to just stay at 4,000, right?
No, you should change it, but if you left it at 4,000, it's fine. It's just, if you change n to be bigger numbers, you get a better answer. N is the number of rectangles. If you change it to a smaller number, you'll get worse numbers.
Okay, yeah, so I'll just leave it up for. All right, so I need to zero. Heading down. All right, you think the people are done? Okay.
Hello. Okay. Yeah. The heck was that? See that? Let's see what we got going on here. This came from our group project of the Zoom meeting. This one is from the quiz. This one is from the quiz. This one is from the discussion one. Well. Okay, let's see what we got going on here. Let's break the breakout rooms. I hate how these lights so off. I'm over here, okay, come on. But if I stay in my little area, they just go off. And you're too far away to make them go on. You have to. Right, how we doing? Are you guys back? Hello?
Yes,
Yeah.
we're back.
Yep.
All right. Alicia. What is 0 times infinity?
Could be anything.
Could be anything. Sebastian, when can we use L'Hopital's rule?
When a limit yields 0 over 0 or infinity over infinity.
Correct. Pamela,
Yes.
what is an inflection point?
When the concavity changes?
Yes, it is. Jonathan. Oh, I don't want that one from you, Jonathan. I want this one. What does the chain rule say?
The derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. I should have known that.
You did. And I want you to remember this. I want you you left the inside alone at some point. So I want you to remember that. Okay, Pavani, what's the relationship between position, velocity, and acceleration?
Hey, I forgot again, but I think it's velocities first.
And then acceleration.
Positions is second, or is it acceleration?
Acceleration is second.
Okay, acceleration is second.
Okay. I already asked Alicia this question. Okay, so what do the two types of integrals tell us?
The area and the antiderivative.
What's the antiderivative of x to the n?
Is it x plus n to the power of n plus 1, all divided by n plus 1?
Okay. Aiden, what's the antiderivative of sine of x?
Is it cosine of negative cosine?
Yes. There you go. Selena, where can we have negative area? Selena? Okay, no Selena. How about Carlos? Carlos, when can we have negative area? When can we have negative area?
When the graph is below the x-axis.
Very good. Luke isn't here, so he can't tell us that sigma notation adds things up. Slade is here. Slade, how do we use sigma notation to approximate area?
Add up the heights and multiply by width.
Yep, that's what we do. And Justin's not here, right? Justin, you're not here, and Keisha's already answered a question. So, how do we find the exact area? Anyone know how we find the exact area? Anybody? Okay, so let's go into mod 10. Those were the questions from mod 10. And by the way, those are not the last questions from mod 10. I'm sorry. We got more questions from mod 10. So let's start off with vocabulary. So the first thing I'm going to do in mod 10 is talk to you about what undoes the chain rule. Jonathan, the chain rule. Remember I emphasized that there was something that was left alone. Let me write that down so you know what the chain rule is. The chain rule said that the derivative of f of a function, an outside function, f of g of x. So everyone see the inside function is g of x? Yes. So what's the derivative going to be? Well, you take the derivative of the outside function and you leave the inside function alone. And then you multiply it by the derivative of the inside function. The important thing is you've left this alone. So what we're going to do now is we're going to undo it. So we're going to do the antiderivative of both sides. Antiderivative dx and the antiderivative dx. Okay? So what are you going to, when you do the derivative of the antiderivative, that cancels out. Okay? And you get f of g. So you can figure out what the function was that they took the derivative of to get what was inside of here. But in order to start this problem, the first thing you're going to do is identify what g of x is. Okay? What was the inside function? Okay? And so that's what we're doing. We're going to undo we have to find the inside function. So, all right, what's the best candidates for substitution? So when you see integrals, if anything, we have a function inside parentheses, that's a good substitution, or anything in exponents or anything in denominators. So let me give you examples of that. So if you have the integral of something with parentheses, sine of x squared times x dx, the inside candidate would be what? You would use the substitution u would be equal to x squared. That would be a good candidate for substitution. Okay. If you have the integral of e raised to the 5x plus 1 dx. What would be a good substitution to let u equal what? What would you let u equal to? What's in the exponent? 5x plus 1. If you have the integral of let's see. You have the sine of x over cosine x dx. I'm just going to tell you, this candidate is the denominator, not the numerator, cosine x. Okay, so inside parentheses, inside exponents, inside denominators. Those are usually what you guess at first. And the letter that you're going to use for all of them is the letter U. So this is called U substitution. We have two more things in here. Well, one is that if U equals the sine of x, what is du? What is the differential? So let's start with the first. If u equals the sine of x, we don't have one for u equals sine of x. What if u equals x squared? What's the differential going to be? What's du going to be? What's the derivative of x squared? Anyone?
2x.
2x, thank you. And 2x, but with differentials, you put a dx at the end. Okay. How about for the second one? What's the antiderivative of the derivative? Now we're not doing antiderivative. What's the derivative of 5x plus 1?
5.
5 dx.
Oh, 5 du.
Okay, that's what du equals. Okay, and last one, as long as I have you, Aiden, what's du going to be here?
Negative sine x. Or sine x. Or no, negative sine x.
Negative sine x dx. Okay. All right. So that's the letter we use, and that's what we do if we have a differential derivative. If u equals sine of x, du equals cosine x. Okay. If u equals cosine x, du equals minus sine of x. Okay. We're going to talk about this last one next time, but let me show you how you can proceed with each and every one of these. Okay. Oop. Okay, so we have this integral we're trying to do, and we know it came from a chain rule because there's an inside function, and that inside function was left alone. Okay, and so that must be what it was. Now, the rest of this x dx, we kind of have x dx. We have this right here, du equals 2x dx. So let me just say this. If that's true, then I could divide both sides by 2. I could divide this by 2, and I could divide this by 2. And those 2's would go away, and then I would have the x dx. Okay? So I have an x dx there, and I'm going to replace it with du over 2. Okay? Now that equals the integral. Oh, it doesn't equal. I can take that thing in the denominator is 1/2. It's just 1/2 times. So I can take a number I can take out. 1/2 the integral, the sine of u du. What's the antiderivative of sine? Someone was telling me, Aiden, what's the antiderivative of sine?
Negative sine or negative cosine. Where'd you get the 9 from?
I would say that 9 is a parentheses. I didn't want it to be minus. So I did a parentheses and then plus C. Okay, fine, not done. Why is it not done? Did my original problem have u's in it? No. So what was the u in this problem? U is equal to x squared. So now I'm just going to take this answer, copy it, paste it, and I'm going to change that u to x squared. Now I'm done. And actually, I can take that minus outside. Put it in front. That. Okay? That's the antiderivative to this because of u substitution. Okay? Let's try the next one. So I have this integral that I'm trying to find. And I said, let the 5x plus 1 be equal to u. Okay, so where is dx then? Oh, I have du equals 5 dx. So can I change that? Can I divide both sides here by 5 so I can get du over 5 equals dx? Now I can take that du over 5 and replace the dx with it. Okay, so that's going to be equal to 1. I take the 5 out, so it'll be 1/5 integral of e raised to the u du. And what's the antiderivative of e to the u? Anyone?
Is it e to the u?
Yeah, sure. The derivative of e to the u is e to the u, so the antiderivative is e to the u. And then plus what? Let's see. Okay, but that's not done because the original problem didn't have a u in it. So you have to back substitute. What's the u equal to here? Waiting for you. Tell me what the u is.
5x plus 1. What happened to du from the second step to the third step?
From the second, oh, I integrated it. It went away with the integral. That's it. Indefinite integral. You'll see that it went away and I got a plus c instead. Okay. All right, well, let me finish this one, the next one here. If you have more questions, catch me afterwards. But so I say u equals cosine x, du equals minus sine of x. So I have a minus sign. I don't have a minus sine of x. I have a sine of x dx. And I can replace all of that. Replace this. Let me take the sine of x out. 1 there. And the sine of x, like that. So now what I'm going to do is take the sine of x out. I'm going to take the sine of x dx out and replace it with minus du.
How about just simply tangent? Tan.
Hold on, no, don't want to do that.
Well, cotangent.
I'll get back to you in a little bit. So, and then this is just 1 over cosine is 1 over u. Okay, or I can write this. So what's the antiderivative of, so this is minus, hold on, minus, what is the integral of 1 over u du? It's an antiderivative of one of the derivatives we're supposed to know. 1 over u du is the antiderivative of what?
X squared?
No. Begins with an L.
Log? No.
Natural log. Yep. Okay, and then we're not done because you have to do what? You have to replace it with cosine equals the natural log. It's actually minus the natural log, sorry. Yes, equals minus the natural log of the cosine of x plus c. Okay, so Eric, this is where I'm going to help you. The original problem can be written sine over cosine is the same as tangent of x. Okay, but we have no way, there's nothing that we know of that the antiderivative gives you, the derivative of it gives you tangent. But the answer is right here is minus the natural log of the cosine. Let me see. The answer is this. But you can take that -1 up. So sometimes you will see that they take the exact same answer. And they take that -1 and they move it up into here and they raise it to the -1. And cosine raised to the -1 is another word for natural log of 1 over cosine is secant of x. That's what you're trying to say, Eric. So that's exactly what this is. It says the integral of tangent dx is equal to the natural log. Oops. Natural log of the secant of x plus c. Okay. Take a look at some of the homeworks. Okay, so in the homework, they give you the substitution for the first problem. They say take, and by the way, this is an ugly problem. I want you to see it. There's something inside a radical. That's what they're letting you be. And this x to the 8th du, it's going to end up being that right there. It's going to be replaced with du over 9. Okay, the 9's going to come out. So you'll have 1/9. Okay, and then that you can do because u to the square root of u is the same as u raised to the 1/2. Okay, so this is a substitution. They give it to you. You can look at the answers for help. Here's another one. They tell you that's your substitution. Boom. Oops. They're telling you what the substitution is. And this square root of x and dx, that's going to come from the differential of u. Because the differential of x to the 1/2 is 1/2 x to the -1/2. Okay. This one right here, they're not telling you what the substitution is. And normally I said use the denominator, but don't use the denominator. You have something inside the radical that's cosine. So if you let u equal cosine x, what's du equal to? What's du equal to? The derivative of cosine. Hello? Lavani, what's the derivative of cosine? Lavani? Hello? Pam, what's the derivative of cosine?
Negative sign?
That's it. And that's going to be dx. Okay, there's this. So in this problem, that sine of x dx will become, that will all become minus du. So this whole thing equals that. So this will be u here, and this, and that will be du. There'll be a minus sign. Okay, the minus 7/3 comes out, and the d that u, that's u to the -1/2. So you do that. Okay, so here's an ugly one. Does anybody see a function inside another function that I can let u equal? look for,
Cotangent?
yes, that's it. And cotangent, do you know what the derivative of cotangent is?
Secant?
It's actually minus cosecant squared of x dx. Okay, so I have this whole thing. It's going to be cotangent is going to be replaced with u minus gone, cosecant squared gone, and dx is going to replace with du. Can you integrate, and the 6 can come outside. Oh, fine. So, all right, can you find the antiderivative of sine? What's the antiderivative of sine? Is it cosine? Or is it minus cosine? What do you think? A sine or minus cosine or plus cosine?
The derivative of sine.
No, the antiderivative of sine.
Oh, negative cosine.
Okay. Now this guy right here, this one's I'm just going to say number 5 is particularly challenging, and it's not one you'd see every day. What you're seeing is an antiderivative that looks like the derivative of secant. It has an x and an x squared minus 1 and a dx. So you could let u equal x to the 7th, and you would get that whole formula. And it would just fall out. Okay. We're not going to do 6 till next time. We're not going to do 7 is also a formula. 8 we're going to do next time. 9 we're going to do next time. 10 we're going to do next time. Okay. All right. So that's the homework you have to do. If you want, you can look at the videos and stuff on let me just say something back up to lessons. So the videos here in Mod 0, the one I'm looking at here is the what did we just do? Substitution? Integration by substitution. Okay. So I just want you to know, here's some examples, e to the 2x cosine of x squared. You can see there's an inside function. These are all undoing chain rules. Undoing chain rules. You can look at these notes, they're handwritten notes. Strategy there. Okay. What I wanted to say is I want to go to this one problem right here, and I want to talk to you about it. No. What are you doing? Okay, I want you to look at this integral of 1 over x squared. Let me just go into Desmos and do it. Anyway, if you have a problem like this, we know that 1 over 1 plus x squared is equal to the inverse tangent of x. Okay. Okay. That's not one of the ones I ask you to memorize, but it is the antiderivative of 1 over the derivative of inverse tangent is 1 over 1 plus x squared, so the antiderivative is 2. Okay? Everyone okay with that? Pavani, can you take my word for that? Yes, can you hear me? Anyway, let me just put it 2. If I put a 2 there, it's just a 2. Big deal. Anyway, what if I put a 2 and an x here? Is that the same answer? No, it is not. Turns out to be the natural log of 1 plus x squared. Let's see. Okay, this is a different problem. This was a substitution. Okay, so to find this was a substitution. Okay, what if you have something else? Oops. What if you have x squared here? Okay, then you have to do long division. Okay, it was in those notes that I had. If you had x squared over x squared, here's the long division thing right here. And you get 1 over 1 plus 1 minus 1, and then you do the antiderivative of that, and the antiderivative of 1 is x, and the antiderivative of that is the inverse tangent. So you get x minus the inverse tangent of x plus c. Okay, and then if you do x to the third, anyway, I'm telling you this because of this. Calc 2 is going to start with this. Okay, we're finishing with substitution, but Calc 2 is going to, actually Calc 2 isn't going to start with this. You know what Calc 2 is going to do? It's going to start with some really fun integrals that help you find the volumes and surface areas of real life things. I used to make it fun by bringing in cake. I would bring cake in, and I would bring a bundt cake in, and we would slice up the bundt cake. And it's interesting because if you slice it different ways, it resembles what you do in trying to figure out the volume of a cake using Calc 2. But anyway, it was fun. The first 2 weeks, fun. And just when you can't drop the course anymore, it quickly turns to the hardest integration problems you ever have. So I just want you to know that those not all integrals have answers, and they're not always easy to see, and Desmos can't do anything for you. Okay. 1 over 1 plus x squared, Desmos might not be able to help. Okay. All right.
Do you teach Calc 2, Professor?
I do not anymore. You're taking Calc 2?
Unfortunately.
You are?
Yeah.
Well, if you talk to me when they put up the schedule, I'll let you know. I think there's a few people teaching Calc 2. I think it's usually Kyle Anderson or Dan Rose. I used to teach it. I don't do it anymore. Actually, I'm not sure I'm doing anything anymore. So I'll let you know next week. But okay, are we good? I think I'm gonna let you go. But if you have any questions, I'm free to answer. Okay. Thank you all for coming remotely.
Good night.
Good night.
Thank you,
Josh.
Professor.
See you Thursday.
See you Thursday.
See you
Thank you.
Thursday. Good one.
Thanks, Professor.
No problem.
Bye.
Take care, Keisha. Bye, Slade. I'm kicking you out.